All right, this is lesson 2-4, transformations, stretch and shrink. So the last lesson we did reflection, which was across the x or y axis. Then we did shifting, which slid the graph somewhere on the grid, right? So left, right, up, or down. And neither of those changed the shape of the graph. But today, when we do stretch and shrink, you're going to see that that graph is going to change its shape as well. So I can identify and describe transformations of functions. That's just still the goal. This is just a repeat slide to tell you that this transformational form can take on any of the functions that we're studying, that we gave to you, the parent functions that we went through in lesson 2. So, and again, things inside the parentheses affect x and things outside affect y. Today in particular, we're going to have a number in place of the b and a number in place of the a. And those are the two values that can stretch or shrink the graph. So for x, it's going to stretch or shrink left to right. And for y, it's going to stretch or shrink vertically or top to bottom. So let's look at how that, a little more detail on stretching and shrinking here. So the coefficient a affects stretching and shrinking vertically. It changes the y values by a factor of a, so it literally multiplies the y values by a. The coefficient b, however, affects the stretching and shrinking horizontally, and it changes the x values by the inverse factor of b. So it's going to divide by b. Okay, so again, it will be opposite with x. So a b value of 3 is a factor of 1/3. So really it's going to cut the x values to 1/3 of their value. So that's what happens with b being inside on x. We're doing the opposite again, okay? So let's just look at some examples here. So is the 5 working on the x, or is it outside the function? Well, it's on the x. So instead of multiplying by 5, we're going to shrink by a factor of 5. Okay. So 3, f of x. Well, this one's outside, and so it's going to affect the y value. So, and you know what? I needed to put horizontally here. There we go. X direction's horizontal, yeah. So 3, f of x is going to stretch by a factor of 3 vertically. Okay, in the y direction, so vertically, it's going to multiply the y values by 3. Next one, f of 1/2 x. Well, you would think that this would shrink, but being on x, it's going to stretch by a factor of, and then just take the reciprocal of 1/2 at 2, and it's going to be horizontally. Okay. Now we've got a number outside and a number inside, so let's do the outside one first. Well, let's go inside first. So it's going to stretch or shrink. Well, it's on x, so it's going to shrink by a factor of 2 horizontally, and stretch by a factor of 2 vertically. And then 1/3 f of x, well, that's outside, so it's going to shrink by a factor of 1/3. We probably ought to put this shrink here as 1/5, okay? So think reciprocal, okay? So 5, 1/5 is the shrink factor, okay? 3, yep, okay. Example 2, write the new coordinates of point negative 4, 9. These are the same ones, I believe, aren't they? Nope, they're different this time. Okay. Some of them are different. I think I may have changed some to make them work out a little better. So f of 4x means we're going to change the x is going to get divided by 4. So it's going to become negative 4 divided by 4, comma 9. And that's going to give us negative 1, 9. 3 f of x. Well, that's working outside, so that's on the y value. So the negative 4 staying the same. And I'm going to do 9 times 3. So it gives me negative 4, comma 27. F equals 1/2 x. Well, it sounds like it would cut it in half, but instead it's going to multiply by 2. And the 9 stays the same, so that gives me a negative 8, 9. 2f, 2x, so each one's going to get something. Negative 4 is going to get divided by 2, and the 9 is going to get multiplied by 2, and that's going to give me a point of negative 218. And then 1/3 f of x, well, that's going to leave the 4 alone, and the 9 is going to get divided by 3. So that's going to give me negative 4, comma 3. Okay? So either multiplying or dividing, okay? So here's some graphs. Here's the exponential function, 2 to the x power. So we're going to start with this f of x equals 2 to the x. And where are we going to place the 4 to stretch it vertically? Well, I'm going to squeeze that out into the front. I'm going to have to move my 2x over here. So it's affecting the y. Vertically is the y. So it's an a value, 4 and then times 2 to the x power. Okay? Graph the transformation given the parent function. So my parent function is x cubed, and 4 is outside. Yeah, 4 is outside because if it were intended to be inside, it would be 4x and then that quantity being cubed. So this is not what we have. We have 4 being an a value, and then x cubed is the parent function. So this is going to stretch the graph vertically by a factor of 4. So this point that's 1 unit above the x-axis actually moves to 4 units above the x-axis, like that. And this point 1 unit below the x-axis right here is going to move to be 4 units below the x-axis. So you can see this graph is going to get extremely steep compared to what it was. Okay. Well, it's not much steeper, but it's steeper, right? So it's gotten stretched. The shape has changed there. Yeah, again, so in order for that 4 to be affecting the x, you would have to put that 4x in parentheses and then cube that. Okay? All right, graph the transformation given the parent function. Well, this time the 1/4 is inside with x, so you would think it would cut all the x values in half, or excuse me, cut them by a fourth, but it's really going to multiply them by 4. So this 1 becomes a 4 here. This 2 is going to jump to be an 8. Oh, I'm doing the wrong way. I'm so sorry. We're doing this in the x direction. So this point at 1 multiplies out to 4. And the point at 2 is going to multiply out to 8. Okay? And so this graph's going to get, let me double check this, please. 1's going to give me a 4th. 2's going to give me an 8th. Yeah, this is right. Yep, it's going to multiply its distance from the y-axis. It's going to stretch it horizontally. And so I'm going to take the y-x values and I'm going to multiply them by 4, not divide them by 4. So Here the x value is 1, and I take 1 times 4, and that's 4. And then here the x value is 2, and 2 times 4 is 8. And here the x value is 3, 3 times 4 is 12. So your graph's going to look like this. Same thing over here. It's going to stretch this thing out like this. And 8, and then 12, and then like that. There's your graph. So think in terms of points, what the x-coordinate is. It's a 1 times 4 is 4. That point has a 2 as an x-coordinate, times 4 is 8. So we're multiplying by 4, not dividing. Okay, because opposite with x, right? All right, the graph of f of x equals x squared is given below. Write the equation of a function that would first stretch the graph vertically by a factor of 2, then shift it to the right 2. So f of x equals, so I have to stretch vertically, that's in the y direction. This is y, so that's the a value. And it says by a factor of 2, so I just keep it 2 times, and then x, it's going to shift to the right 2 units. Well, that's affecting x. And so I have to put parentheses so I can put my shifting value inside the parentheses with the x. So right would typically be plus, but because it's opposite with x, it's left 2, so negative, or excuse me, right becomes negative 2, and then put your square on the parenthesis. So this x minus 2 shifts the graph right 2. The opposite of minus 2 is plus 2, right? That's right 2. And then this 2 out front affects the y value, so it stretches it vertically by a factor of 2. So it looks something like this on the graph. So this point would shift right 2, but then double in height. And this point would shift right 2, but double. And so the graph would be steeper. Let me see if I can do a little better here. So the graph's going to get steeper. And it's going to shift to the right. Okay? It's going to grow steeper faster. That's what the 2 does. All right, so you'll find the second half of that Delta Math assignment deals with stretch and shrink, so you can give that a try now.